Hello everybody, and welcome to part 3 of my video series on Plantinga's modal ontological argument. Links to parts 1 and 2 of the series are below, and you should probably have seen at least part 1 of this series before watching this one. In part 1 of the series, we said that Plantinga's modal ontological argument is an ontological argument given within a formal axiomatic system called S5 modal logic. So in this part of the series, we are going to study S5 modal logic and its relationship to the modal ontological argument. Now, S5 modal logic is built on top of S4 modal logic. S4 modal logic is built on top of modal logic, and modal logic is built on top of propositional logic. So to start with, we're going to discuss propositional logic. In propositional logic, we deal with propositions, which are also called statements. Loosely speaking, a proposition is an assertion that must be either true or false, but cannot be both. Examples of propositions include, unicorns exist, my dog has fleas, it's raining outside. If P is a proposition, the negation of P, called not P, is the proposition with the opposite truth value as P. So that means if P is false, then the proposition not P is true, and if P is true, then the proposition not P is false. So for example, the negation of unicorns exist would be no unicorns exist, or equivalently, unicorns do not exist. Two propositions are logically equivalent if we can show, using logical reasoning and unwinding definitions alone, that they must have the same truth value, either both true or both false. For example, Jim is a bachelor and Jim is an unmarried bachelor are logically equivalent because the definition of bachelor includes being unmarried. These two propositions either have to both be true together or both be false together. If P is any proposition, then P and not P are logically equivalent. For example, so if P is true, then not P is true, and if P is false, then not P is false. Logically equivalent propositions are in a sense equal as far as propositional logic is concerned. They are interchangeable in arguments. To demonstrate one is true is to demonstrate the other is true. Anything that can be proven using one can be proven by using the other. If P and Q are two propositions, then the assertion if P then Q is called a conditional, and it is true if and only if it cannot be the case both that P is true and Q is false. So for example, if Jim is married, then he is not a bachelor, is an example of a true conditional, because it is logically impossible that Jim could be both married and a bachelor. If I will jump into the pool, then I will get wet, is another example of a true conditional, because it is physically impossible that I will both jump into the pool and I will avoid getting wet. There are different kinds of conditionals corresponding to different kinds of impossibility. Our first example here was a logical conditional. Our second example was a physical conditional. There are also metaphysical conditionals. However, in the modal ontological argument, at least in this video series, we are only going to be interested in logical conditionals. Now, the contrapositive of the conditional if P then Q is the conditional if not Q then not P. Notice that we reverse the order of the P and the Q and we put nots in front of both of them. If P then Q means that it cannot be the case that P is true and Q is false. If not Q then not P means that it cannot be the case that not Q is true and not P is false. But that means the same thing as saying it cannot be the case that P is true and Q is false. So a conditional and its contrapositive are logically equivalent. As far as propositional logic is concerned, they are interchangeable. An example of this is the contrapositive of if Jim is married, then Jim is not a bachelor is if Jim is not a bachelor, which is the same thing as saying if Jim is a bachelor, then Jim is not married. These propositions are logically equivalent. As far as propositional logic is concerned, they are interchangeable. Because they are logically equivalent, they must be both true or both be false, and in this case, they are both true. They both mean it cannot be the case that Jim is married and Jim is a bachelor. In addition, the propositions if P then Q and P only if Q are logically equivalent. P only if Q means that it cannot be the case that P is true and Q is false, because P can be true only if Q is true. So, for example, the propositions if Jim is a bachelor, then Jim is not married, and Jim can be a bachelor only if Jim is not married, are logically equivalent. Now consider the propositions. If I will jump into the pool, then I will get wet. It's contrapositive. If I will not get wet, then I will not jump into the pool. And the only if version, I will jump into the pool only if I will get wet. These are all logically equivalent. As far as propositional logic is concerned, they all mean the same thing. They all mean it can't both be true that I will jump into the pool and false that I will get wet. However, despite that, I don't think they feel the same. If I look at the first conditional, it makes sense. If I will jump into the pool, then I will get wet. Well, because the pool is full of water, so of course. But when I read the second two, they sound a little weird. If I will not get wet, then I will not jump into the pool. I will jump into the pool only if I will get wet. In the second two, it's kind of sounding like I'm making the decision not to jump into the pool unless I get wet. What's going on here? Well, in informal speech, when we say if P then Q, we usually mean to imply that P happening in some sense causes Q to happen or leads Q to Q happening. We usually mean this to say that if P happens, then Q will happen because P happens. And if P and Q occur in time, we usually mean to imply that P comes before Q in time. But propositional logic does not deal with causality or time. It is only concerned with the logical relations of the truth of various propositions. So, as a result of this, when analyzing a conditional proposition, it can be helpful to look at its contrapositive. Even though the contrapositive will be logically equivalent to the proposition, sometimes some things may appear to be more intuitive in one form of the conditional than in the other. So that's propositional logic. Now, modal logic builds on top of propositional logic. In modal logic, in addition to being true or false, now every proposition is either necessary or contingent, but not both. That leads to 4 combinations for propositions. Propositions can be necessarily true, such as 2 plus 2 equals 4. They can be contingently true, such as horses exist. They can be contingently false, such as unicorns exist. Or they can be necessarily false, such as 2 plus 2 equals 5. Necessarily false propositions are called impossible propositions, and a proposition is possibly true if and only if it is not necessarily false, that is, not impossible. There are many different axiom systems for modal logic. Each axiom system consists of a different set of axioms for reasoning about possibility and necessity, and each axiom system is designed to model a different type of possibility and necessity. In this video series, we are only going to be concerned with 2 modal axiom systems, S4 modal logic and S5 modal logic. We begin with S4 modal logic. S4 modal logic is meant to model apodictic modality, which we discussed in part 1. It is the logic of provability, demonstrability. It is an epistemic modality of what in principle can be known. S4 modal logic has actually been used in the study of mathematics to study provability. For example, it's been used in a proof that the continuum hypothesis cannot be proven true or false using the other axioms of set theory. I'll put a reference to a book on this in the description below. Some axioms of S4 modal logic include, if a proposition is necessarily true, then it is true. That makes sense in a logic of provability. If I prove a proposition is true, then that proposition had better be true. It also makes sense in a logic for classical philosophical ideas about the nature of knowledge. Classically, philosophers have assumed that if we say someone knows, that if we say so and so knows such and such is true, then such and such is actually true. Another example is, a proposition is not necessarily false if and only if it is possibly true. This one actually is not special to S4 modal logic. S4 modal logic inherits this from kind of generic modal logic. If you think about it, it makes sense. Another axiom is, if a proposition is necessarily true, then it is necessarily true, it is necessarily true. Again, this makes sense in a logic of provability. If I prove that a proposition is true, then not only have I proven that that proposition is true, but by doing that, I've also proven that I can prove that proposition is true. And this also makes sense in a logic for classical ideas of knowledge. Classically, philosophers have assumed that if we know something is true, then we also know that we know that it is true. So this is not a complete list of axioms from S4, although it does include the two big axioms that S4 adds to kind of generic modal logic, but this is not meant to be exhaustive. Well, now let's go on to S5 modal logic. To introduce S5 modal logic, we are going to explore a question. In modal logic, a proposition can be both true and possibly false. For example, the proposition horses exist is both true and possibly false. If we're speaking metaphysically, this would mean that it is true horses exist, but there is a way the world could have been such that horses wouldn't have existed if the world had been that way. But could a proposition be both true and not just possibly false, but possibly impossible? For example, could it be the case that horses exist, and yet it is impossible horses exist? If we're speaking metaphysically, that would mean, could there be a way, even though horses exist, could there be a way the world could have been such that not only would horses not have existed if the world had been that way, but it would have been impossible horses could have ever existed if the world had been that way? So that's the question. Okay, so S5 answers this question no. S5 modal logic starts with S4 modal logic, so that every axiom of S4 modal logic is also an axiom of S5 modal logic, and then it assumes an additional axiom. If a proposition is true, then it is not possible that proposition is impossible. So in the cases of horses, since it's true horses exist, it is not possible that it is impossible horses exist. An equivalent way to put this is, if a proposition is true, then it is necessarily true that that proposition is at least possibly true. So if a proposition is true, then it is necessarily true that that proposition is possibly true. Now, this axiom does not make sense in an apodictic modality, an epistemic modality of provability, where saying something is necessarily true means it can be proven to be true. Just because a proposition is true doesn't necessarily mean we will be able to prove it is possibly true. Even if it's true, we might not know it's true, and we might not be able to know it's true, and we might have no way to prove it's not impossible. So this axiom is not appropriate for a modality of provability, and that's why we did not add this axiom to S4 modal logic. That's why we're only adding it now to S5 modal logic. This axiom only makes sense in a metaphysical modality, a modality about what is necessarily true, not about what can be proven to be necessarily true. So according to S5, if a proposition is true, then it is necessarily true that it is possible it is true, regardless if anyone is able to prove it is possibly true or not. So, if a proposition is true, it is not possible that it is impossible, it is true. Let's take this axiom and restate it in logically equivalent forms. To begin with, we'll replace a proposition with its negation. So this becomes, if a proposition is false, then it is not possible that it is impossible that proposition is false. Okay, so saying that it is impossible a proposition is false is the same thing as saying it's necessarily true. So this is the same thing as saying if a proposition is false, it is not possible that that proposition is necessarily true. Well, that makes sense. If a proposition is false, then it is not possible that proposition is necessarily true. So for example, unicorns don't exist. So from that alone, we know it's not possible it could ever be necessarily true. Unicorns exist. Taking the contrapositive gives, if it is possible a proposition is necessarily true, then it is true. So if it is possible a proposition is necessarily true, then it is true. This is the form of the axiom we will need for the modal ontological argument. And in this form, the axiom may perhaps appear to be counterintuitive. Wait, just because it's possible a proposition is necessarily true, somehow magically that means the proposition is true? How does that work? Well, remember, we are no longer working in an epistemic modality where saying something is possibly true means that it cannot be proven false. This does not say that a proposition must be true just because we can't prove it is not necessarily true. This axiom is perhaps best understood in its only if form. It can be possible a proposition is necessarily true only if it is true. So what this says is we're no longer working in an epistemic modality where we can assume it's possible a proposition is necessarily true just because we can't prove otherwise. This says, working in S5, if we want to demonstrate it is possible a proposition is necessarily true, at the very least we have to demonstrate it is true. So if it is possible a proposition is necessarily true, then it is true. By combining this axiom with the other axioms that S5 modal logic inherits from S4 modal logic, we can demonstrate a stronger version of this axiom is true that also has to be true in S5 modal logic. We will not need this stronger version of the axiom for the modal ontological argument, but we will include it here for completeness and also to help better understand S5 modal logic. So if it is possible a proposition is necessarily true, then not only must that proposition be true, but that proposition must be necessarily true. So if it is possible a proposition is necessarily true, then it is necessarily true. Now, this, if anything, is even more surprising than the previous version. And when I first saw this, I thought it was very confusing. What? Just because it's possible a proposition is necessarily true, somehow, magically, it follows that the proposition actually is necessarily true? How does that work? Well, the first thing to remember is that we're not working in an epistemic modality any longer. And this doesn't mean a proposition is necessarily true if we can't prove it isn't. That would be ridiculous, and that's what this would mean if we were working in an epistemic modality. What this axiom actually means is that working in S5, if we wish to demonstrate it's possible a proposition is necessarily true, we have to demonstrate it's necessarily true. Working in S5, if P is a proposition, it makes no sense to say, I'm not saying P is necessarily true, I'm just saying it's possible P is necessarily true. There's no such thing as just saying it's possible P is necessarily true. If we say it's possible P is necessarily true, we are saying P is necessarily true. In S5, it cannot be contingently possible that a proposition is necessarily true. Another way to put this, and I think this is what's going on at a deep level, is that working in S5, whether a proposition is necessarily true or not, is itself something that does not depend upon the condition of the world. Okay, so that's S5 modal logic. Now, let's go to the modal ontological argument, and I'm giving a slightly different form of the argument here, because now we have the S5 modal axiom system to use. Premise 1, it is possible a maximal great being exists. Premise 2, if it is possible a maximal great being exists, then it is possible it is necessarily true a maximally great being exists. Premise 3, if it is possible it is necessarily true a maximally great being exists, then a maximally great being exists. Conclusion, a maximally great being exists. Okay, the first thing I want to clarify is that every premise in this argument is referring to metaphysical possibility and necessity. The first premise is really saying it is metaphysically possible a maximally great being exists. The second premise is saying if it is metaphysically possible a maximally great being exists, then it is metaphysically possible, it is metaphysically necessarily true a maximally great being exists. I just didn't want to have to write the word metaphysically over and over and over again. So when we're doing the modal ontological argument, possibility and necessity means metaphysical possibility and necessity. This is my favorite form of the modal ontological argument because every premise of the argument neatly separates out one of the significant assumptions the modal ontological argument depends upon. For example, premise 2 depends upon the definition of a maximal great being. It can't be possible a maximal great being exists unless it is possible as necessarily true a maximally great being exists, because a maximally great being is defined to be a necessary being. Therefore, if it is possible a maximally great being exists, then it is possible it is necessarily true a maximally great being exists. Premise 3 depends upon S5 modal logic. In S5 modal logic, in order for it to be possible a proposition is necessarily true, the proposition must be at least true. So if it is possible, it is necessarily true a maximally great being exists, then it must be true that a maximally great being exists. The argument is valid. It's of the form P, if P then Q, if Q then R, therefore R. So this argument is valid, and premises 2 and 3 may not be contested because they follow from the definition of a maximally great being and an axiom system that we're assuming. So once again, the challenge is verifying premise 1 of the argument. But I don't want to go into that right here. We've really covered that in the previous parts of this video series. Instead, I want to talk about a specific argument I frequently heard made about the modal ontological argument. So I've heard people say things like, the modal ontological argument shows that if it is possible a maximal great being exists, then a maximal great being exists. Therefore, the modal ontological argument places an additional burden on the atheist. Before the modal ontological argument, the atheist must challenge the proposition God exists, either by arguing it is false or at least arguing we have insufficient grounds to hold it as true. After the modal ontological argument, the atheist has to prove a maximal great being doesn't exist. They have to show the definition of a maximal great being is incoherent. That way, we can derive a contradiction from the definition of a maximal great being, the way we can from the concept of a married bachelor. Perhaps by trying to argue that omnipotence is self-contradictory or something like that. So the problem with this is that it says the atheist has to prove a maximal great being doesn't exist, that we can derive a contradiction from the definition of a maximal great being. These are forms of epistemic possibility. There is nothing, absolutely nothing in the modal ontological argument that says if no maximal great being exists, then the concept of a maximal great being will be epistemically incoherent. There is nothing, absolutely nothing in the modal ontological argument that says if no maximal great being exists, then we will be able to logically derive a contradiction from the definition of a maximal great being. So that, of course, leads to the question, so as a result of that, the atheist does not have to demonstrate that it is epistemically impossible a maximal great being exists. The atheist must demonstrate that it is metaphysically impossible a maximal great being exists. That leads to the question, what must the atheist do to show it is metaphysically impossible a maximal great being exists? So that's the question we're going to cover for the rest of this video. What must the atheist do to show it is metaphysically impossible a maximal great being exists? Well, to answer this question, I need to make a few remarks about logic and reality in general. First of all, reality exists before our attempts to reason about it. Reality exists before we make definitions and axiom systems to model it. By themselves, our definitions and axiom systems cannot change reality. We cannot define something into existence. Rather, if we are lucky, the definitions and axiom systems we create will successfully model what was already there. In addition, our propositions don't change reality by being true or false. Rather, our positions are true or false depending on how they correspond to reality. Again, reality comes before our attempts to reason about it. So suppose, purely for the sake of argument, that in reality, God did not exist. Again, just for the sake of argument. And here I'm defining God not as a maximally great being, but simply as an omnipotent, omniscient, perfectly good being. Forget about possible worlds and all that for the moment. This is the notion that typically that of God that atheists are typically expected to challenge. So suppose God conceived of just as an omnipotent, omniscient, perfectly good being in reality. Don't worry about possible world. Suppose that God did not exist. Now, part of the definition of a maximally great being is that it is omnipotent, omniscient, and perfectly good. So if in reality God didn't exist, then there would be nothing in reality corresponding to our definition of a maximally great being. So then the proposition, a maximally great being exists, would be false. And since we are working in the S5 axiom system, it would follow that it was not metaphysically possible, that it is metaphysically necessarily true, a maximally great being exists. And then, since our definition of a maximally great being requires that it be a necessary being, it would also not be metaphysically possible a maximally great being exists. So if God did not exist in reality, and again, this is just for the sake of argument, then it would not be metaphysically possible a maximally great being exists due to the way we've defined a maximally great being and due to the axiom systems we've assumed. But then what if someone says, but the idea of a maximally great being appears to be perfectly coherent to me. I can conceive of it perfectly in my mind. Intuitively to me, it seems metaphysically possible a maximally great being exists. Surely that means it's at least metaphysically possible a maximally great being exists. Well, when I was a little child, I sometimes wondered to myself, I can conceive of myself being Superman. So why doesn't that mean that I can be Superman? And the answer, of course, is that's just not the way things are. Just because I can conceive of myself being Superman doesn't make it real. Reality precedes the definitions and axioms we create to model it. And if in reality God did not exist, then we've defined our terms and assumed an axiom system in which it would be metaphysically impossible a maximally great being exists. So, what does the atheist need to do to show it is metaphysically impossible a maximally great being exists? To show it is metaphysically impossible a maximally great being exists, it is sufficient for the atheist to show God does not exist. Now, let me hasten to add, I'm not saying the atheist can do that. That is not my point. My point is that before the modal ontological argument, the atheist was supposed to show God doesn't exist. After the modal ontological argument, the atheist can show it's impossible a maximally great being exists by showing God doesn't exist. In other words, defining a maximally great being in such a way that a logical consequence of God not existing is that it is metaphysically impossible a maximally great being exists places no additional burden on the atheist whatsoever. Okay, so that's it. In conclusion, the modal ontological argument works by assuming a modality and defining a maximal great being in such a way that it cannot be possible a maximal great being exists unless a maximal great being exists. It then concludes correctly that if it is possible a maximal great being exists, then a maximal great being exists. But this does not help to demonstrate a maximal great being exists, because to show it is possible a maximal great being exists, we have to show a maximally great being exists. And that really is, when you boil it down, all there is to it. Okay, thank you very much for watching my video series. I hope you enjoyed it or found it informative or whatever. Thank you all.